In the world of Docker, obviously we're talking about software, and sometimes in the world of software, things break. And so we have a couple of guys from our customer success team, Ada and H, who are going to walk you through some troubleshooting tips just in case something breaks when you're running Docker. So guys, take it away.
Thanks. I'm Ada Mancini. This is troubleshooting tips from Docker support engineers. This is the third version of this talk. I'd recommend going back and watching the last two versions of this, because we're kind of moving the goalposts on what we want to talk about in each one of these sessions. But today, I kind of felt like Alice here in this tweet, and as I was starting to put this together, I was agonizing over how do I explain and distill all of the thoughts and techniques about troubleshooting Docker and Kubernetes into a 40-minute talk. And it feels impossible, like trying to explain Zen or the art of motorcycle maintenance in just 40 minutes. So what I want to talk about today is some of my experiences and personal philosophy towards troubleshooting and debugging, and hopefully give you some tips that you can take back so that you can solve problems on these complex systems in your own environments. So Docker EE, we know, has grown more complex over the years as we've added multiple orchestrators running in parallel under a single management plane. The management plane itself is an application running on Docker Engine. So how do we generalize a problem-solving methodology for fixing problems in these complex systems? At its most basic, we need a strategy that is going to be evidence-based and repeatable. And so in my personal experience, I usually lean on a simplified version of the scientific method that's based in characterization, a test and analysis, and communication. And this always begins with asking the right questions. This is the most important step in the process because it sets you on a path for everything that follows. It's said that the formulation of the problem is often more essential than the solution. This problem statement here, somewhere, somehow, something has changed. It's kind of an irrefutable problem statement. There's nothing in there that you can prove is incorrect, but it's kind of one of the worst things that you could say to a support person or the help desk. It's like, it doesn't work. And that really gives us nothing to go on. What does work even mean to you? What does it mean to me? Those things can be very different. So working out the problem and framing it in a way by forming a complete description of it is extremely helpful in leading you towards a solution. It often leads you towards that direct discovery, kind of in the same way that you may talk to a rubber duck. Like having this conversation, this inner dialogue, and working out the problem with yourself is very, very valuable. It frames all the work that comes after it, and it saves us time, which takes us from a potentially infinite set of problems down to a manageable domain, something that we can actually solve. So what is the problem generally begins with asking measurable questions like, what do I expect to happen in my environment? And how is the reality that I'm seeing different from the thing that I expect? In order to understand what I generally expect to happen, we really need to know what the normal is in our environment. So this involves gathering real data from things like monitoring tools, testing, profiling, logs, the Docker and Kubernetes command line interfaces. And when we start to understand what the normal behavior of our system is, we can really understand when that reality that we're observing starts to differ from our expectations. We're gathering this data and we want to form a theory to explain our observations, which really is the trickiest part because we like to think that we are rational beings, but the mind really isn't that rational. And research says that even the way a question is asked can influence and skew your judgment. A malformed problem statement will often lead to a wrong train of thought or gets you stuck on one particular approach, which can cause you to miss the forest for the trees. So always remember to take a step back and consider the bigger picture as well whenever you're working on any kind of problem solving or debugging or troubleshooting process. And again, trust but verify. So all the information that you're getting from your instruments, from other people, from your environment, Trust that this information is true and right, but also verify that you're not being lied to. Everybody lies, and we may have heard this before. This is House's axiom. You figure out what you know, and then research what you don't know, try and find the differences. And when you realize what you do know and what you don't know, you craft a theory, and that theory is then testable. To test that theory, we want to make some measurable changes to our environment or to our process, to our application. And these measurable changes need to be documented from beginning to end. What was changed and what were the results that, what was the result afterward? This is the only real way to make those kinds of rational decisions that we're getting after about what we're observing. It becomes even more important when we're communicating with other people, because we need to understand how the thought processes that brought us from point A to point B throughout this, following this path. In particular, we want our tests to be performed in a repeatable way so that they can be reproduced. In particular, infrastructure as code, reproducible infrastructures, systems like Puppet and Ansible, Chef, they make it really easy to track these kinds of changes that we're making to our infrastructure and applications. They make this process version controllable. We can roll back changes to a known good configuration and examine the thought process that led us from A to B. In particular, tools like Vagrant, Linux Kit, Docker certified infrastructure, stacks, they really aim to fill this particular need for having a reproducible set of steps for troubleshooting methodology. And we want to refer to some existing models or use models that we're already familiar with in order to explain and frame our observations. But don't be too beholden to them. Be ready to throw them away. Always be able to, or always be ready to check the assumptions that you've made and take a step back if you find out that they're incorrect. In particular, some models or visualizations that we want to use and combine are being able to view our software or environment, our complex system, as a stack or as an onion from the inside out. In particular, a Docker Swarm service that's composed of a stack of related services. Each service has multiple tasks. Each task is inside a, or each task contains a container. And in particular, request flow that might model the movement of an API call or a request through the different elements of a system. And combinations of these models, like the stack and the request flow, may be involved in profiling the way that your HTTP application works. And finally, when we reach a point of conclusion, we want to share our results with the world. I say always begin at the beginning. Always start at the start. Information that's held in one person's head doesn't help very many people. It might solve your problem in the here and now, but if this problem comes back up again in the future, or if someone else has this problem, we really want our information that we've discovered through this process to be widely distributed and shared so that it helps everyone. So how many times have you maybe found yourself on a troubleshooting path and you found yourself in a situation like this where you found a thread on Stack Overflow or a forum and a problem statement that seems eerily similar to yours but absolutely no follow-up and nothing actionable. It's fixed now, or an abandoned thread that leaves you with nowhere to go. You don't want to be like Denver Coder here. You want to share the results of all of your problem solving and troubleshooting analyses so that it helps the world, so that it helps more than just yourself. In particular, there are communication problems that can present themselves if your conclusion is that you need to ask for help and you need to go out to other sources and you need to involve other people in your research, the communication aspect is very important. And if you find yourself trying to solve problem X, but you think that solution Y might be your right answer, make sure that whoever you're communicating with understands what X is, because what you think the solution might be could be completely off base and you may not know the right answer. And you're leading someone else down the wrong path. In the help desk, we typically call this kind of thing the XY problem. So this is a conversation that I had with someone on IRC, which I participate in a lot with the community. And someone was saying, I want to access the SSH server in my container, and I don't really know how to do that. And that's not something we usually recommend to people that run SSHD alongside their program so that they can get into a container. It's usually easier simply to Docker exec into it and then use the tools that are available. But we find through this conversation that the real goal that is trying to be achieved here is actually just to run an application, run a GUI application. They're trying to figure out a way where they think that in the past they've probably run an application from a remote system by using something like X forwarding, and they're trying to apply that same technique to containers. It's a good thought process, but not really the ideal way of running a GUI application inside a container. Much simpler just to simply bind the X control socket and run Firefox directly, for example. So we want to avoid these kinds of XY problems whenever we're communicating. We always want to start at the start, explain our thought processes that brought us to the problem that we're seeing and what we think our solutions might be. And finally, we want to ensure that in our communications we offer a low barrier to entry, or we want to ensure that there are a few barriers as possible to sharing the information that we've found. Pick the easiest, lowest effort method for sharing information amongst your team, your organization, and the world. For example, plain text is really easy. I find that Git is really easy, and on the support team we typically tend to keep all of our resources in shared Git repos that all of us can edit and update and share with each other. How this philosophy kind of shakes out in application is that typically I tend to see that problems fall into sort of an intersection of three overlapping domains. Configuration or logical, like does my application actually do the work that I think it should? Communication problem between elements of the system, that might be something on the network, or compute resources like CPU, disk, memory. So when examining logical or configuration issues, we're usually digging into our application in some way. We have multiple orchestrators running on Docker EE, and in that sense, these orchestrators right now don't share too much information between them, but we want to drill down into each individual unit of orchestration and examine what's happening inside our application. So we're trying to go from a very high level overview where all of our services are running in this amorphous cloud, and we want to get into these individual units of work that are behind these units of orchestration. In particular on Docker Swarm, that might be a SwarmKit service, and on Kubernetes it might be a Kubernetes deployment or a replica set or just individual pods. So with the Docker command line, there are ways to look at that high level Docker service LS, drill down into the successive layers of this onion, almost like peeling it back. So we make calls from the outside of the onion towards the inside, and as we go from the outside towards the in, we get more and more detailed information about the specific conditions of our running application. The same can be done in Kubernetes. The command line is just slightly different, but basically the same. These onion models are very similar. Kubernetes pods could have several containers running into them, so at the very lowest level, that's the main difference between a SwarmKit service and a pod. With our services in particular, the very lowest level, the inspect data, gives us some really powerful introspection tools into like the state of our application. The status you can see here is running. The OOM killed flag says whether or not our kernel has tried to kill our application because of an out of memory condition. We can find the PID of our application. We can find its exit code if it's exited, started at and finished at date. All of this information is extremely valuable in putting together timelines and correlating the data that we see from our research gathering phase with our observations about the state that our application is currently in. So one thing that I have seen over the last couple of months is that I would really suggest that anyone operating or developing on Docker EE take some time to learn some of the more advanced command line usage abilities of the Docker and Kubernetes command line. My favorite little tricks right now are to build structures that provide easy loop and list processing. So with the Docker command line, -q flag is a fantastic way to just print out a list of IDs for whatever resource that you're interested in looking at. And there is a filter flag that lets you filter out based on various pieces of metadata: image name, container name, label, whether or not the process is running or not, if it's been exited. And then in the second example here, we also have a format string. It lets you take any of the JSON, the JSON data elements from the inspect data from a container and format the output so that you're only seeing the information that you're actually interested in getting. So the second example here, Docker PS, we are filtering out for any container that's running that matches an image named nginx. And we're just formatting the output so that we display the name of that container. And on a swarm, you'll see the host name that the container is running on, and then the name of the container itself. Learn to love the Docker command line and the kubectl command line. They're very, very powerful. And Bash in particular offers us some really cool shell constructs for loop and list processing. Command substitution and IO redirection can be used to build very advanced shell constructs, and external tools like xargs and JQ and curl allow us to really easily interact with Docker and kube APIs and with our applications. So almost all of the Docker command line tools can output their data as JSON. JQ is a fantastic command line tool for manipulating that JSON data. And curl, I'm sure a lot of you are familiar with, that speaks HTTP. It's a great way to interact with programs, test things functionally. Is my application working? You could curl your HTTP front end to make sure that it's returning the information that you expect. A lot of people use curl in their health checks to make sure that their applications are still healthy and returning a valid HTTP result code. And with a combination of these constructs, you can really easily go from this high-level Docker service LS view to a individual container data. This is a Docker service LS, or we take a Docker service LS. We know that we have a service called foo running in our application. And we're interested in getting the container data for each task from that service. So Docker service PS, we're processing lists based on a filter for any task that is running right now. Send it through a couple layers of xargs and pull out specific bits of information to pass to the next piece of the pipeline. And JQ in this example is just pretty printing all of this for us, so it makes it nice and easy to read. These shell constructs and the Docker command line can also give us really powerful ways to look into our environments. So this is a pattern that I've used before that it may be kind of tough to read, but essentially what we're doing here is like a generalized way to get information from any node in the cluster. I've plenty of times have been involved in a situation where we need to get some information from the perspective of each node in the cluster. And without an existing tool like Ansible or Puppet in place that would allow you to reach into all of your nodes, Docker can be used to do the same kind of thing. So in this example, we create a globally replicated service which will create one task on each node. We use a restart condition of none to make sure that that task never restarts. It only runs once. And essentially, we've created a batch job that just runs one time on every node and then exits. And we are mounting the Docker socket so that our service can speak to the Docker API. And then we pass a command into the shell so that we exfiltrate some of the data that we're interested in. This was an example that I used in a customer environment so that we could examine the state of all of the overlay networks from all of the nodes' individual perspectives. Finally, at the very bottom, we take advantage of Docker CP to reach into all of those containers and pull all of the information down into one place so that it's really easily examinable. We don't have to SSH into every single node and then get all those results individually. For examining the state of the network, like I said before, using existing models can also be very helpful. In particular, the OSI model, or the simplified version that represents so the TCP/IP stack in Linux. So at the lowest level, we're checking things like physical connectivity between two hosts. Like, are the cables plugged in? Are the link lights on? If we log in and we examine the ARP tables, like, do we see ARP broadcasts and MAC address registrations from other containers in the network? Moving up a little bit, we are checking connectivity between containers at the L3 level using tools like NSLOOKUP, ping, and netstat, IP route and IP adder to make sure that our routing tables are all correct. Moving up a little bit more, we're doing things with TCP and UDP and like functionally checking the fact that a TCP connection can be made between these two containers on a particular port, or that we're sending UDP packets and those are being delivered. Moving further up the stack, yet again, we're using tools like curl to make sure that the results that we're getting back are actually what we expect. So two containers could be talking to each other, and two containers could be responding to each other based on netcat, but if they're not actually the containers that we expect they are, L7 could fail. Like, curl could give us results that are not what we expect. If the container that if our destination isn't actually the container that we would expect it to be. In swarm overlay networking as well, or actually let me go back. TCP dump, finally, is a very, very powerful tool. TCP dump kind of gives us an overview of all of these layers down to the data link layer. TCP dump inside of a network namespace and then inside of a container namespace would give us visibility at both ends of a connection, like in the case of swarm overlay networking. So I've stolen this slide from last year's conference. And with this, in this model, a container namespace exists for each container attached to an overlay, and then there will be an overlay namespace for each overlay on a node. So if we need to get a complete picture of the request as it leaves a particular swarm service on overlay, we'll need to create a TCP dump inside the container namespace and then on the other side of it as well. So we're going to exec into the we're going to run a container inside the network namespace of our container 0, run TCP dump on port 80. We're going to start examining traffic as it leaves that container. We're also going to run a container inside the overlay network that's not attached to any other particular container, just inside the overlay. We can TCP dump port 80 there as well, and then we see our packet moving between the various layers of the swarm overlay networking. This could be repeated on the other end in our destination. So if we need a real, complete idea of what's happening to our data as it moves between the various layers of swarm service or swarm overlay networking, we might run another set of 2 of these on the C1 namespace and the overlay on the other side, on the other node. To talk about some Windows troubleshooting specifics.
Okay. All right, 60 minutes. Okay, my name is H. H Kitagawa, and people just call me H, so it's easy to remember. And I made this presentation about Windows troubleshooting, assuming you are mostly Linux admin. But how many of you have run Windows nodes in production? Oh, there you go. Oh, okay. Okay, there are quite a few. Okay. Well, you might find it a little bit boring, but the whole object, I wrote this whole thing assuming you're mostly Windows person. And I'm going to start this by exercise. So you have a cluster, and you used to work fine with Linux, and now you have Windows node. And then your dev asks you, my web server on IIS is down, help. And a lot of time, people just shut off. I don't know Windows, I don't know what to do. This happened to Ada too. And many of my colleagues, especially our developer, had the same problem. So let's make it easy. Let's say, if this were Nginx web server on Linux, how would I approach? Now you know how to do this, right? It's not difficult once you know how to work with the ECP cluster. So yeah, you're going to probably ask, is the service running? Can I connect to it? What does the log say? Can I run vanilla image for comparison? And chances are you already know how to do this. And Ada already did that as well. So let's do one by one. Is the service running? And again, we start doing that in Nginx on Linux. I'm not going to go into too much detail because this will overlap Ada's section. But you probably do Docker service ls, find out the service, which service you're dealing with, and then you peel the onion, look into the service Nginx with Docker service ps, and then finally you check the node using Docker node ls. And you know there that Linux worker 01 is the one running Nginx. So how do you do that on Windows? It's not much difference, right? Because it's a Docker stuff. So you see Docker service ls, Docker service ps against IIS service instead of Nginx. And you do Docker node ls, and right there you know that Windows Worker 01 is the one that's handling the load. So let me do this. It's very similar, right? So you already know the first step. So don't tell your Windows guy, this is Windows, it's not my business. Don't do that, okay? All right, and that's my objective here. So, and next one is, can I connect? How do you do that in Linux? You already know. You run the curl. It's web server, so it really doesn't matter where you do it. And then next step, again, you do from the previous slide, you know which worker node is in charge. So you do SSH, connect to the worker node, do a Docker PS, figure out what ID you're dealing with. And then maybe if you have to do a Docker exec IT interactively, and then get inside of the container and check your config file, etc., etc. And again, let's do that on Windows side. Curl is curl. You don't have to log into Windows node and do it, right? You just use the whatever the handy node that you have, run the same thing. Instead, this time you just call it against myiis.org. So you already know how to do this. But when you have to get into the node, this is where the difference begins. But still, it's not that bad. You actually do Docker ps, same command, and then do a Docker exec, figure out the ID, and then get in. And this time, instead of SH, you do PowerShell. And yes, PowerShell command is a little different, but we have a solution for that later on the later slides. All you have to know is invoke web request is actually equivalent to curl, and you just make sure that the core 200 will return, meaning web server is running. So again, this is not that difficult, as you can see. And then this is where it gets a little bit messier. What does the log say? And on Linux side, you do, because this is UCP, you don't really have to worry about the whole thing, but just remember, the last line says Docker UCP 301 support. So this will actually invoke the command that will gather the information for you and stick that into Docker support tar. And lower half is basically doing the same thing. It looks very different, but don't worry, you don't have to remember. We have that on the doc. So just remember docs.docker.com EE get support. And if you get there, we have the doc for it, and you can basically copy and paste it and run the whole thing. So again, this is not that difficult. And then fourth one, can I run a vanilla image for comparison? Again, on Nginx side, it's fairly simple. Docker service create Nginx. How do you do that? And on Windows side, again, you just stay on a Linux manager and run the same command, with a different image name, of course. And I put the colon nano server in red because by default, Microsoft IIS colon latest uses a base image called Windows Server Core, which is like 10 times larger than nano server. So you will have to wait a while just for the simple test. So for the first round, it's usually a good idea to add that colon nano server. And if you're still not convinced, we have a cheat sheet for you. And just remember this URL, success.docker.com article Windows cheat sheet. And actually, this used to be internal documentation because we have, ever since I joined Docker a year and a half ago, I do introduce myself. I'm the first hire for Windows engine. Everybody said, oh, I'm afraid of Linux. So I started making this list as an internal effort, and it turned out everybody liked it. So I made it public only last week. And I have things like this. Let's say, how do I do how do I get the environment variable? And you just do that PowerShell command. Or how do I grab it? It's actually find string on PowerShell. So you don't have to go through, Stack Overflow each time and look it up. You don't have to do that. And this should probably cover most of the stuff, at least on the first swipe. So this is really handy tool. And then I have this thing, assuming you have a default install, in Linux, how do you fiddle with a host file? You know how to do that, but maybe you don't know a way to find it on the Windows side. Then there's a translation, so you can do that with this metric. So again, just remember Windows cheat sheet. That should be a handy tool. And feel free to give us feedback so I can keep expanding this documentation. All right. So, and then we still have to talk about non-parities for Windows. Microsoft developers are really aggressive. They close down the parity really quick, but there are some few stuff. So let's cover that. So for a few more months, be aware of no IP layer routing mesh on a GS side, on a stable release. No Kubernetes support yet. Again, as we all know, this will come. This is already working in many cases, but if you call us for support, it's not on a stable release, so I can't quite help you yet. But, and the containers are hidden behind that. But if you want to give it a try, if you go to get the Windows Server semi-annual release, IP layer routing mesh is already working since end of last year. So it's already available. People are using it. Again, it's a semi-annual release, so maybe not in a production. And then, of course, Kubernetes support is coming really soon, so you're good there. And there are the small things are already put them together into this another KB article of mine. And just remember what are non-parities, Windows, Linux, and IBM-Z. So this is a good place to get all the information. And then I'm going to talk about Microsoft and Docker partnership. So this is from the perspective of a support engineer. So it's a little different from marketing speaking. And if there's any conflict, they are the right one, I'm the wrong one, okay? But anyway, so I'll just read it. Docker is the only container runtime on Windows as of today. And Docker engine was developed through collaboration. So what that means is it's not really Docker doing all the work or Microsoft doing all the work. Microsoft did a lot of work to make change to the Windows to make it happen. And even on this is actually kind of old diagram, but this explains the best. If you see the upper half on the green box and the light blue one, that's the Docker stuff. That's mostly Docker project stuff. And then lower half is Microsoft. But even for the upper half, Docker project, now Moby, is one of the biggest contributor in that project is actually John Howard from Microsoft. So expertise is on both sides. And they work together, like they interact all the time. And then Microsoft support provide container support. Docker and Microsoft support work together. So what that means is if you have, say, single Windows node, have issue and file ticket to Microsoft, they should be able to help you. And of course, we can help you too. And on the back end, we are connected together. So if Microsoft get the Windows container case, they can help it. They will escalate it to myself or my counterpart. And we work together. We do joint call. So it's not two companies working separately. We are actually connected on the back end. Okay. So this collaboration makes a little bit confusing environment. I get this question a lot. And customer would say, hey, I have this issue. I have this question about Windows container. Who can help me? To whom should I file a case? And this is a general guideline to give to the customer. Start with Microsoft support for issues reproducible with the Docker run, or reproducible on Windows Node only cluster, or related to Windows host itself, of course. Start with Docker support for issues related to UCP or DTR. Those are, they're developed by our developer, of course, so you should call us first. And I said start with because there may be a case where I get the case of that's seemingly about UCP, turn out to be Microsoft. I will tell the customer, hey, why don't you open the ticket with Microsoft too? And then give me the case number to me. And then when that happens, I'll just talk to the Microsoft peer, say, hey, mutual customer of ours filed this case number, and this is the number, so let's work on it together. And we go for maybe a three-party screen share session, and then walk through it. And of course, we will involve Microsoft and the Docker developer. And this is better explained on my, again, yet another KB article of mine. And just remember the URL, where to get help with Windows. And finally, so this is the biggest message I want to say here. Don't be scared. Because I get this a lot. Because I know nothing about Windows. Most Linux expert, again, like super Linux expert, like Ada. And because I'm no Linux expert, Windows expert, me, because I don't consider myself as the Windows expert. I actually am a jack of all trades. I touch all kinds of stuff, so I'm not comfortable calling myself expert yet. So, because if my demonstration explains anything, what it does is you already know the answer. It's just you don't feel comfortable in that environment because it has Windows. But you already know the answer. And when I'm really scared about Linux case, because I also take Linux case too, I tell myself this. Fear is a mind killer. Fear is a little death that brings total obliteration. And I completely get how you feel, because I'm also afraid of certain Linux case. I do it anyway. And more often than not, I know the answer. So just get over the fear and give it a try. All right, so any question?
We've got there's a microphone here in the center if you want to ask questions, or I've got a roaming mic if you want to just raise your hand and I'll come and track you down too. I think we're good.
Sounds like we're good.
Good job, guys.
Thank you, everyone. Thank you.